So here's another spooky term that's completely harmless. So object index signatures, what are those? So when we don't know the properties of an object ahead of time, but know the shape of the values, we can use index signatures. So let me just first show you an example. Pokemon, it's going to have a name, it's going to be Pikachu. So there are two ways to access a property on an object in JavaScript. The first one, you already know, it's the dot operator, you can say Pokemon name, and the other one is referred to as an index accessor. And this is really what's important how TypeScript works, because this is reflected in the type system where you can add an index signature to unknown properties. So the alternative is of course name. So how does that help us? In this example, I have an example of an API response from the Pokemon API, and you can see at all of these properties, right? And you're not going to spend hours trying to type everything out, and some of them can really go deep and you have really no option, right? So how can you remedy this where the alternative is only to use the type any? So you can say interface Pokemon API response, and then we can specify what's the key of those values, and each of them is a string, right? So that's really only the consistent part here. So we can do that by saying index string, and that's it. And for the other property, we can say unknown. So even if we want to use it in our code, we have to have checks and balances in place so our code doesn't explode. And this is really awesome. So let's look at an example how we can use it by specifying some types that we want. So in the example, we might only care about some properties and not the rest. So we can keep this Pokemon API response, but we can specify the ones we care about and we know exist. But again, you're lying to the TypeScript compiler because you can't really guarantee what's returned from the API, so you might really want to have checks in place, right? So we can say number, but this is really going to help us in the short term for auto-completion. You can say name string, and then here is a bit more complicated. We're just going to say that it's an array, but you can also type it many other ways, right? You can say it has a property ability, name string. As you can see, you can like spend or waste hours like typing these API responses, which really isn't a great use of your time, right? But maybe some kind soul already did it, and there's also ways to generate types based on the response from an API, which we're going to look at later, which is really awesome. Yeah, so we can say move. So name is a string and URL is going to be a string. And yeah, that's really it. So let me just copy over the API here. And then let's create a get Pokemon function, same as we did before. Yeah, so we can say argument is a name, that's a string. And then it returns a promise that's going to be the Pokemon API response, right? And it's really not complicated, right? So we can define the function body, we can say const response, same thing we did before, wait, fetch. And then let's say API. Can also get the name. Then let's say const Pokemon await response JSON, and then let's return the Pokemon. Yeah, so we now also have a function that's log Pokemon, and let's see what this is complaining about. So we need to update our config to include the target, I think. So let me try this. Let's say target. Let's just say ES next, so the latest version, so it doesn't bother us. Let's see if that fixes it. Yeah, that fixes it. So we can continue creating the log Pokemon async function, because TypeScript has to be aware of what environment it runs, and it's like, hey, I really think this is Node or something, and we really don't support fetch. But I think Node does support fetch right now, so I'm not really sure. But yeah, that's what the problem is about. Yeah, so we can log Pokemon name. We can say const Pokemon await get Pokemon. We can say name. So here is the part that's going to be interesting. So we can say Pokemon order to string. And when we hover over this, it's going to say, hey, object is of type unknown. Like, you really need to make sure that you have checks and balances in place, because this really might not exist. So if we say Pokemon order, we can say as number, again, type assertion. So if you're aware this exists, etc. And then it's like, okay, we're chill now. So you can say to string, because it knows it's a string, right? So this is really interesting. And we can also get great code completion for the properties we know about. So you can say Pokemon abilities for each. Yeah, and then we can even destructure it. So we can say Control spacebar, and we can get, let's see, do I get ability? Ah, I guess not. Let me just see. Console log ability name. Okay, it does work. So yeah, you get great code completion and everything works great. So let's look at another example that's really trivial, but it's an example. So yeah, let me just close this. We can delete all of this code. So let's say we have a rating and we have an interface of Pokemon ratings, and we already have some Pokemon specified such as Bulbasaur, Charmander, Squirtle, but we really might add other Pokemon and we don't know what they're going to be. So we can use this instead. So we can define first a type rating. We can say the literal type, right? 3, 4, 5. And then we can create an interface, Pokemon ratings. And then again, we can say that the index key is going to be a string, the name of the Pokemon, right? And it's going to be of type rating. And then we can specify for Bulbasaur, going to be rating. Charmander also has a rating. It's a really trivial example, but just to give you an idea, right? And we can also say Squirtle rating. So yeah, you can do some crazy things. This is a great opportunity to explain something that might confuse you when dealing with dynamic code, where you're accessing object properties such as object key. You always have this example where you have some object and then you want to dynamically enter its key. So you're going to encounter this problem and you might scratch your head and lose hours over this, but I'm going to save you that time by explaining you why it happens and how you can avoid it. So let's just create an interface. Stats, we're going to have an ID number. HP is going to be number. Attack is number. And def is number. Then let's create an interface Pokemon. We're going to have Bulbasaur, going to have stats, right? Charmander is going to have stats. And Squirtle is going to have stats. So let me just copy over this object over, so we don't have to type this for half an hour. So here is the big error you're going to see. So for example, if we do const Bulbasaur, and I'm typing a string here on purpose because this only happens when it's not inferred literally, and you're going to see. So another thing is you can also do let, and this is going to cause the same error, because if you hover over Bulbasaur, you're going to see this is a type string. So remember our previous lesson about literal types, and this is now going to make sense why this error happens. So let's say we have some dynamic code and we say Pokemon, and then we say Bulbasaur, and boom, this is an error. And this is the most cryptic error ever. You're going to struggle with this. So no index signature with the parameter of type string was found on type Pokemon. What does this mean? If you're seeing it for the first time, literally nothing, and you probably hate TypeScript and want to quit. But if you understand this, you're going to love TypeScript. So basically, as we learned, this isn't inferred as a literal type. So how can we circumvent it? This is a const. This should work, I think. Yeah, it fixes it because Bulbasaur is now literally inferred as a type Bulbasaur instead of being a string, right? Which is really beautiful. And that's what's expected when we're accessing it dynamically, right? So this is really an important concept I want to iterate over and make sure you understand it. So TypeScript thinks we're trying to access the object property by using a string index when objects are numbered index by default. In reality, we want to access the Pokemon object using the type literal Bulbasaur instead of the type string. And you can also see this is true if you change the index signature to string, meaning you can pass anything that matches that index signature. So yeah, so you can change the Pokemon here to, here right here is the Pokemon. You can change like this. You can say Pokemon string stats, and this really isn't the solution because this isn't what you want. You just want to use the literal type Bulbasaur and make sure you're passing the literal type, right? So as I said, what you should do is make sure you're passing a type literal instead, or use the sconst assertion. And in this example, I'm only explicit, so it's obvious, but using const already does that. So if you look at this example again, const Bulbasaur, we made it a string here so we can trigger the error. But yeah, make sure you're passing the string literal Bulbasaur. And once you understand that, you're going to understand why this error happens and you can prevent it from happening. So catch you in the next one.